Okay, let us see. Uh, any one of those who are telling there are three outputs, can you come online? Just for a small discussion, nothing else. Somebody who said three outputs.
Yes, sir.
Yeah, can you just tell me where do you
Sir,
mark those outputs?
sir, it's two, sir. I think I thought it wrongly the first time.
Okay, you changed your answer.
Yes, sir. I mean, the brake and the mass, they have the same displacement.
Okay, no issues, no issues. The one who said one output, can you come online?
Yes, sir.
Yeah, where do you mark that output?
So I took it at M itself.
M itself. Okay, fine. Do you think there doesn't exist any other displacement in the diagram?
Technically, you will have three separate displacements from K, B, and M, but final displacement will be movement of the entire body itself.
Okay, so three. You say there may be three.
Okay, fine. Yeah, then there may be three. If you take individually, then three. Yes, sir.
Okay, that's fine. Anybody else wants to argue your point? So you are free to open. I don't think this is I will evaluate your knowledge and all by your answers, whatever you give. Don't worry about that. Participate freely, share your opinion, where you go wrong, understand. It should be in every class. Yeah.
So even I think too.
Okay, to those who are telling too that let just hold on. Huh? Someone is telling. I heard some girl's voice. Please explain your point.
No, sir, I was telling that it may be two and I was trying to justify why.
Yeah, you can justify. One of you can justify why it is two.
Sir, I'm not too sure, but I
Mhm.
think because the spring has one fixed end and one free end. So
Okay.
one of the displacements would be at the free end of the spring and between the damper.
Very
And
good. Okay.
the other displacement will be between the other end of the damper and the mass.
Other end of the damper and mass.
Yeah.
Okay, that's fine. That's okay. Anybody else? Any other answers? The discussion is open for everyone. I feel there is no meaning in solving the numerical and giving you the answers. The more you participate, the more everyone will come to know. It's always better to know what's wrong or how many possibilities of going wrong than only knowing what is right. Anybody else? Okay, nobody? Okay. So don't blame me later for not giving any opportunity. We'll proceed. So see, this system has actually, as she explained, it will have two output variables or outputs in the diagram. So the explanation was correct. If you apply the force, at this point, okay, wherever the mass is present, obviously this damper will have a relative displacement. Okay, because the one free end is connected to the spring, other free end is connected to the mass. So for damper, both are free ends. Okay, is it clear? For damper, both are the free ends, whereas for the spring, only one end is free. So just by looking at this dynamics, one can easily follow that this force will obviously impact on all the three elements. Okay, on all the three elements without any doubt. Therefore, one end of the damper will have a different displacement and the other end of the damper will have a different displacement. So look at the free end of the damper which is connected to mass. Okay, so whatever is the displacement occurred by this mass, the same displacement will happen to this damper also. Okay, for this end. And because of some frictional effect, okay, present in the damper, the displacement occurred at this point will not be same as that of the displacement occurred here. Okay, so if you imagine that if there is no damper present, then the displacement here and here would be same, but there is a damper present here. Okay, So which makes this displacement Hello Ganesh, can you hear me?
Yes, sir.
Yes, okay. So the displacement at the mass point is not equal to the displacement at the end which is connected to spring. That is obvious. So therefore, we only will have two output parameters. Those who thought of three might be marking x1 here, x2 here, x3 here. Okay. So you are wrong. Your output variables or your prediction of output variables does not obey the fundamental physics of laws of mechanics. So you cannot mark the outputs according to number of elements. That is one key concept here. So we'll proceed. Any doubts on this explanation? Can stop me?
Sir, spring will also have some movement due to friction, no? Like it will have some displacement due to friction.
Yeah, that is obvious. Let us see. I will proceed. You can understand when I solve the numerical. You can ask me doubt later also. So I'll mark this point and call it as say one point where displacement is x1 of t and another at mass x2 of t. Okay. So this x1 of t will define the displacement of the spring at this free end, also the displacement of the damper at this free end. Okay. So spring displacement of the spring is also defined equally with respect to x1. Then obviously this mass block will have a displacement x2 of t. So what what I would like to highlight here is don't be under the impression that wherever there is a mass, there only exists a displacement output variable. Don't be under such impression. Okay. So those who said one or thought of one output variable, don't be under such impression. So you should understand concept and then mark the output variable. So I hope I'm clear. And the one who had asked me about the displacement of spring, I hope you are clear. Okay.
Yes, sir. I thought you didn't consider that. That's why I pointed out.
No. I will give time and later I will write. You can wait and watch. Then you can ask once the numerical is completed. You can ask doubt at any time. Okay. Next job is to mark the equivalent diagram. So go for the equivalent diagram. So how do we mark the equivalent diagram? I'll give hint and then write. So f of t as the input here. Then we will have two nodes x1 of t and x2 of t. Okay. So think before writing and parallelly observe what I write. Okay. So I said some points during the beginning of the subject. So parallelly observe and tell me whether whatever is written is correct. So we have one node, we have another node, then B is common between both the nodes, then M is connected to one node and K is connected to other node. So I will hold on for a minute. Any comments regarding this diagram? Regarding the equivalent diagram?
Sir,
Yes.
why is M connected to X1 and K to X2?
If you ask
Isn't it
me
the
like
other way
that,
around?
yes.
Okay.
Okay. Anybody else has got this doubt? Anybody says this diagram is correct? Or anybody saying this diagram is wrong? Any one of you can come and tell me why it is wrong.
So they're interchanged, X1 and X2.
Okay. Anybody else?
Displacement, sir. X1 and X2.
Okay. That is. I hope it is clear for everyone. This is one intentional mistake. I said earlier, whatever I write is not always correct. So don't blindly follow me. Okay. So this should be x2. This should be x1. Or you can take this force element and connect it here. So both way it is correct. So this is simple thing everyone should understand by this point now. Okay. So this diagram is wrong and make a small correction and proceed for differential equations. Write the differential equations and then find the transfer function. I'll give 4 to 5 minutes for everyone. This is a very simplest one. So please proceed. Please proceed towards finding the transfer function. And I will ask randomly the answer. Anybody is not able to write the differential equation can share your doubt or ask your doubt here. I'll explain. So make the correction and then proceed. Don't follow this diagram. So I'll read out the first differential equation if anybody wants. At x1, we have 0 equal to, because there is no input at all at x1. 0 equals to, then what should be written? M d square x1 by dt square, M d square x1 by dt square. Please stop me if I am wrong. I'll just spell it. You have to follow my explanation. Okay, 0 equal to M d square x1 by dt square plus B dx1 minus x2. B into d inside bracket x1 minus x2 divided by dt. So this will be the node equation at node 1, and at node 2 we have f of t equals to k into x1, sorry, k into x2 of t plus b into dx2 minus x1 by dt. B into dx2 minus x1 by dt equals to 2. Okay, once you know the differential equation, directly apply the Laplace transform, then you will get the
Can you repeat it once? I couldn't get that.
which equation?
Both, sir. I think I got them wrong. That's why.
Okay, at node x1, you have 0 equal to, because no input is applied,
Okay.
m d square x1 by dt square, because mass is present.
D square x1 by dt square. Okay.
Yeah. Then b is a common element.
Okay.
So b, it should be d into d inside bracket x1 minus x2, close the bracket, divided by dt.
Okay, sir.
Is it correct?
Yes, sir. Fine.
So I hope you remember we assumed x1 to be greater than x2. That's why it is x1 minus x2.
Okay, sir.
So the second equation goes like this. Since input is applied at node 2, it starts with f of t equals to. Fine. F of t equals to kx1, sorry, kx2 plus b dx2 minus x1 divided by dt.
Okay, sir.
So the rest all is simple. You can apply Laplace and form a matrix. Okay. Then apply Cramer's rule. Yesterday I have told the Cramer's rule. Then use Cramer's rule to get the transfer functions. So I'll ask the answers randomly. I will give you 2 more minutes to solve.
Excuse me, sir.
Yeah, tell me.
Sir, you said the equations before the four equations at node both the nodes.
Yes.
Those equations were after shifting the force element the other side.
Yes, you have to shift.
Okay, sir.
It is not shifting. I wrote wrongly. You have to correct it.
Okay, sir.
Okay. Okay, Amok TD, are you able to solve? Amok TD. Okay,
No, sir, still trying.
still trying. Okay. Dhruv, are you able to solve? Okay. Gautam Sharma.
Yes, sir.
So it's a simple, right?
Yes, sir.
Okay.
Writing the poem.
Okay, no problem. Karthik Patil.
Yes, sir. Yes, sir.
Okay.
Yes, done, sir.
Okay. So Karthik, can you read out what is x1 of s by f of s?
So, S square m plus SB by delta.
S square m plus
SB by delta.
sb by delta. Delta is determinant. Okay.
Yes, sir. Determinant of 4 and 9. So,
Fine. So everyone, those who have done, please check out, cross check your answer. If it is wrong, just let me know. S square m plus sb divided by delta is x1 by f of s. Karthik, can you read out what is x2 of s by f of s?
SB by delta.
Pardon, once again.
SB by delta, sir.
sb by delta. Just
S into B by delta. Yes, sir.
okay, fine. Puneet VH, are you getting the same answers? Rahul Bisht. Riaz Basha. Sumit. Tejas. Are you getting the answers? Should I wait or shall we go for the next numerical? Those who have not done.
Wait, sir.
Okay. Should I post the answer for this numerical?
Yes, sir.
Yes, sir.
Okay, how many say yes? Just those who want, please say yes. And your name?
So, Ramok Mishra.
Rohit.
Sir, Dipanshu, sir.
Ronak, sir.
Yes, sir.
Dheeraj, sir.
Only very few want to know the answer. Rest all are following? Okay, I assume the rest of the students are following. So that's really good actually. And those who said want the solution of this question, please try to maintain notes of every class. This is why it helps for you. There's nothing big I'm doing. It's very simple. Only the Cramer's rule part. If you would have copied the previous numerical, this was easy. So I think
Yes,
you
I copied. I'm still not able to understand. That's why I'm asking.
that's why
I understand.
that's why I'm asking. That's why you have to tell. So all those things
Sir.
are
Sir, can you just go back to the previous slide?
slide. What exactly you want to
Yes.
see?
The equivalent diagram, sir.
Equivalent diagram. I
Yes,
said we have to shift. What I have drawn here is.
So I just.
Can you see this?
Okay, sir. Okay, sir.
And this f of t you have to shift here because it is wrong.
Yes, sir. But actually, if we shift and if you do, we'll get this answer, sir. This one, what I told just now. But actually, the force.
Nothing wrong. If you have got different answer or different way,
No, sir. No, sir.
I can share.
Karthik only, sir. Same answer, I'm telling.
Mm-hmm.
But actually, we are applying force on M, sir.
Mm-hmm.
So then it
So,
will be MD.
force should be on M side itself, no, sir.
And that okay, you mean to say accordingly we should change x1 and x2 also.
Yes, sir.
That's fine. That's fine.
Yes.
MD D
Did
square
I
H2 by
forget to
dt.
tell that? Did I forget to tell that? Okay, sorry for that. I think I forgot to mention that we should shift even x2 also. x1 and x2 alone. We should interchange.
No, sir. The doubt is actually we should shift the force on spring side or mass side, sir.
It is on mass side only. It is with respect to node x2.
Sir, we just have to shift the x2t and x1t. That's it,
Yes,
right?
we
Yes,
should
yes,
exchange
that's it.
x1 by
That's it.
I didn't understand.
Yeah, that's it. Did I tell it wrongly? I think I told to shift
Yes,
force.
sir, yes, yes. Yes, sir.
Yeah.
Sir, that's why it took some time.
So then answer will be like the
Uh-huh.
first x1 by s by fs. F of
Minus
s will be k plus sb by delta.
Okay.
No, sir,
second
no,
one
sir, no, sir.
minus sp by delta.
Yes. Second one sb by
Sir,
delta.
sir, if you take just interchange
1
x1
minute.
of 20, we
Mhm.
get x1 of s by f of s is equal to minus sp by delta.
Okay.
X2 of s by f of s is equal to sp plus k by delta.
SP plus k by delta. Yeah, yeah, yeah. Fine, fine, fine. Let me see.
That's what I got confused took some time.
Let me check my notes. Huh?
Okay, sir.
Mhm. Okay. So that's fine. I will post this complete answer once again. So those who didn't get answer or got confused, please listen to me once again. I think I consider different numerical for explanation. Okay, sorry for that. Just forget everything. Come back again. X1 is here. X2 is here. Force is applied to the mass that is at the node x2. Okay, don't follow this explanation. So the diagram I had drawn here is to ask whether it is right or wrong. Okay, so somebody said x2 and x1 should be interchanged. Fine. So x2 and x2 should be interchanged is the correct one. Nothing more than that. But if you draw x1 and x2 like this, and if you want to apply force at x2 node, you can shift it here, and accordingly this k and m will also get shifted. So I think I forgot to tell that point. Okay. So with that, everything is simple. I think now Amog Mishra can understand.
Yes, sir. Yes, sir. Now I got it.
Yeah, yeah. Okay. It's mistake from my side. I think I should have
No
told.
problem, sir. It's fine. It's fine.
So we'll move on to the next type of numerical. Everyone, please let us proceed. So this is another typical numerical. So we have one mass block M1 and we have another mass block M2, then K1 and K2. Just don't think that how this type of system exists in real. Okay, all that those things are irrelevant as of now. So just think how we can get the transfer function for this. So for this numerical, just to make things simpler, I will mark x1 and x2 both, and let me explain how x1 and x2 are decided. So we are applying force f of t here. So because of that, m1 will get shifted to shifted to some distance. Ganesh, can you hear me?
Yes, sir.
Yeah. So x1 and x2 are marked here. Force is applied. M1 will get shifted to certain distance. Because of this force, K1 will also get impacted, and because of that, M2 will also move to certain distance. And we have K2 here. We have K2 here, which is connected to M1 and this rigid body. Fine. So if x1 and x2 were not given, you should be able to identify the displacements. Fine. So you can ask me why x1.
Is there no friction between M1 and the solid floor?
Okay, okay. There is a friction. There is a friction. I forgot to write it, but I will
Okay.
consider it while solving numerical. There is a
Okay.
friction. There will be a friction, and there is no other friction considered here. So proceeding with this, We have to write the equivalent diagram now. Again, please observe carefully. Wherever I make mistake, you are free to point out. You can comment on it. See, one thing I would like to clarify everyone, my way of teaching is quite different. I always expect or initiate some thinking process in your brain. Okay, I could have easily mark everything and draw equivalent diagram, write differential equations, solve it and go. But I don't want that to happen, because anything can be remembered by you only when you make mistakes in that. Okay, or only when you do it by yourself. That's what I believe. And all these things, whatever I'm teaching now, are not so complicated. It's very fundamentals. Okay, so that's why no need to bother. Even if you don't understand, no need to bother. Eventually you can follow it when you refer notes or any textbooks.
So will there be any pseudo force here? Like if you see from the outside of this box, then there might be some pseudo force applied on the mass.
That we ignore actually. Okay, in real case or practical scenario, there will be, but in this specific numericals, we ignore that. Okay.
Okay, sir.
As I said, ideal conditions. So in such conditions, whenever you want to analyze any system or anything in general, we often ignore all practical things actually. Okay. When you design a controller, say for some aeroplane, so at the initial stages, when you start with some elementary approach, we ignore the air friction part. Okay. So, and we test that algorithm. So similarly, there will be some practical parameters, but when we do it in the ideal conditions, we will ignore it. Okay. So to proceed further, at x2, okay. So I didn't write k1, which is common to x1 and x2. So now it is written. So can everyone follow why k1 is appearing here as a common element? Because it is between this mass block whose displacement is x1. So if I mark x1 at this end, it means the whole mass block will get displaced by x1 only. Okay. So this displacement is x1 and this m2 has a displacement of x2. So k1 is in between those displacements. Or in other words, k1 has both free ends. Okay. So m2 is appearing at this point. And we have a friction B1 between this mass block M1 and ground.
Sir, won't K2 be common for x1 and x2?
What?
Won't K2 be common for x1 and x2?
What? K2 be why K2 is not common for x1 and x2? You mean to say?
Yes, sir.
Is that is your question? Why K2 is not common between x1 and x2 or something else?
Yes, sir. Same.
So K2 only one end is free, which is connected to x1, and the other end is connected to this rigid body. So this end of K2 is not free. So it is as good as connecting to ground only. So we, I mean ground in the sense not electrical ground. In the other end connected to this point means it is not free end. I hope it is clear.
Rigid side.
Yes, rigid side. So this is your equivalent diagram. Consider f of t here at the input side, and then we can proceed. So find the transfer function of this. Okay, so is there any correction in this diagram or any mistakes? Check out carefully because this is quite complicated numerical. You should be able to draw this equivalent diagram yourself. So if equivalent diagram is done, then the rest all is very simple. You need to write the differential equations, apply Laplace. Again, this is a 2 cross 2 matrix, and where you have to apply Cramer's rule. Okay, so at max you will have only 2 cross 2 matrix. There won't be any 3 node examples. Okay, 3 node examples. So at max you can have only 2 nodes. So is it clear for everyone? I am winding up the mathematical modeling for this type of mass spring damper system.
So can you give one or two more questions? Just
Okay.
just to practice.
Okay, just for practice, I will definitely give it. I request you to proceed and solve this. Meanwhile, any doubts, any clarification you can ask, because today I will wind up with MBK, mass spring damper systems, and these specific mechanical systems are called as translational systems. I'll explain it again in the next class anyhow. So this MBK, mass spring damper, are called as translational systems. So I will wind up the mathematical modeling for translational systems, and in the next class I will consider rotational systems. Okay, rotational mechanical systems, where instead of linear displacement we will have angular displacement. Angular displacement, angular velocity, and angular acceleration. Similar type, not much difference. Only the representation of elements will change, and instead of x we will have theta instead of f. What is the equivalent parameter for f in rotational system? It's torque, rotating force. Fine. So that's it for today's class. Then thank you all. Bye bye.
Thank you, sir.
Thank you, sir.
So just send the extra questions, sir.
Sure. I have planned to send extra questions. I will not stop by solving only 2 or 3. I will definitely send more questions. But let me think. Should it be better to send after teaching all, or should it be better to send now only? I will decide it. Huh?
Okay, sir.
Okay.
Thank you.
Okay.